We're going to start today's lesson looking at a brand new type of question. So in this problem, we're talking about barbecue. At a barbecue, you can buy hot dogs for $2 and drinks for $1. You spend $12. What are the possible combinations of drinks and hot dogs that can be purchased? So we're not going to go through the whole thing and say, I don't know, I had 6 hot dogs and 0 drinks, or 3 hot dogs and 4 drinks. I don't know what the math is. But what I'm interested in is coming up with an equation that would represent all the possible combinations. So if it's $2 per hot dog and X is the number of hot dogs, that'd be 2X. And if it was $1 for drinks and Y was the number that represents, or the letter that represents drinks, then I could come up with an equation like this. 2X plus Y equals 12. And if you look at it, this equation does represent this scenario, but it looks very different than the types of equations we've been looking at. So I'm going to go to Desmos and ask what this equation looks like. 2x plus y equals 12. See what it looks like on a graph. So I'm going to go here and go 2x plus y equals 12. Turns out it's a straight line. So that's a bit of a surprise to me because normally the lines that we've been doing, the equations have been y equals mx plus b. And this one looks completely different. So I'm just going to make this a dash line and go to this next line and see if I could figure out what the y equals mx plus b is for this line. So if I wanted to calculate the slope, I would have to go from here, let's go all the way down to here. So down 12 over 6. So first off, it's down, so it's going to be negative, and it's down 12 over 6. 12 over 6 is 2. So y equals negative 2x, and then we would say our plus b, and our b is our y-intercept. In this case, it's 12. And we get the exact same line. So it's really curious that this equation up here represents a straight line, and this equation also represents the same straight line. That means there must be a different version of equations that also describe straight lines, and that's what we're going to look at briefly today. 2x plus y equals 12 is called a line in standard form. So what's standard form? It's just a different version of writing equations for lines, but it's written like this, with a number in front of an x plus a number in front of a y plus just some regular constant equals 0, or like the one we see, ax plus by, and have it equal a number. These are said to be in standard form. So why is there a different version? Well, you see in that other example, it made a lot more sense to talk about X and Y having hot dogs and drinks than trying to figure out the rate of change of hot dogs you're eating versus the drinks. Not easy to figure out a y equals mx plus b for this scenario, but very easy to come up with this relationship. So having this different version of an equation of lines will be helpful in some situations. However, for grade 9, most of the situations we're going to do, the y equals mx plus b version of an equation line is way more helpful. For example, finding the slope and the y-intercept. It's much easier in this version. Now, when you write something in standard form, there are some conditions or rules for standard form. A has to be positive. And this is just a notation that mathematicians have agreed on, that the letter in front, or the coefficient in front of x, has to be positive, and there can't be any fractions. Now, we're not going to spend too much time on these rules or putting it in standard form. What's more important is knowing if we end up with the equation that is in standard form, could we change it into y equals mx plus b to figure out the slope and the y-intercept? If we go back to our graph, or to this equation, it's difficult to figure out what the y-intercept is and the slope just from looking at this equation. We actually had to go and graph to figure it out, to see, oh, the y-intercept was 12 and the slope was negative 2. That wasn't obvious from the equation. So knowing how to go back and forth is really what's going to be most valuable, so that we can figure out the slope and the y-intercept, regardless if it's given to us in standard form or in the more easier version in slope and y-intercept. So that's what we're going to do today. So I could go off and show you all the algebraic steps here and go through and do the lesson this way, but I think it would be much easier to visualize the algebra if we use our new tool, Graspable Math. So what I've done is I've taken the same questions, but written them in this way. so that we can use this graspable math. If you haven't been playing around with this in the post that I made last week, you might want to go out just get familiar with it, or you could learn the steps from here. All right, so let's look at that first example. 2x plus y equals 12. I know what it turns into this equation from Desmos, but could we do it without Desmos? Well, in order to put it in y equals mx plus b form, we need the y by itself, which means we have to get rid of this 2x. To get rid of it, we have to do the opposite operation, the inverse operation. So if you remember to do inverse operations, you're going to click and hold on the equal sign. So by doing that, you get this e, which stands for the equation. And anything you do here will be an operation that's performed to both sides. So I'm going to go minus 2x. And you see that it subtracts 2x from both sides. Now, I'd like to do 2x minus 2x, because those are like terms. But I can't do it because they're not beside each other. But what's great about Graspable Math is I could take this equation, this 2x, and come and join it with the 2x. Now I can put it right next to it and then collect like terms that way. Or, undo, I can take this whole 2x term and just put it over top of it. And of course, 2x minus 2x is 0, and it's gone. And now we have an equation like this. That almost looks y equals mx plus b. The y is on the left-hand side by itself, and the letters and numbers and everything else is over here. But in order to have it in y equals mx plus b, I like to see the x first. So I'm just going to grab this and put the x first. And now it looks like y equals mx plus b. And now that it's in y equals mx plus b, I can quickly read that the slope is the coefficient on x is negative 2. So I'm going to go and fix these y-intercepts. You know, I've just made them 0 for all these questions, and they're not really 0. We have to figure them out. But now I can see that the slope is that. So to change this m from a 0 to a negative 2, I'm going to go and click on the white circle and just type in negative 2. Remember, the slope is negative 2. It's not negative 2x. The coefficient is the slope. It's negative 2. And what's the y-intercept? The y-intercept is 12. So I'll go back here, click on that, and change that to a 12. And I've now successfully figured out that the slope and the y-intercept of this equation is negative 2 and 12, just like my graph. Okay? So that's our goal today, is to take equations in any version, whether they're in standard form or something other like that, to put them in y equals mx plus b to get the slope and the y-intercept. Now, because this is graspable math, we can actually do another really cool thing. So I'm going to take this example and show you another way to do it. You'll notice that when I take 2x and I subtract 2x from both sides, it disappears on the left side and appears over on the right side, because I'm subtracting 2x, subtracting 2x. It feels like that 2x has moved straight over to this side and changed its sign. And kind of does, because to subtract 2x from this side, it disappears, and subtract 2x over here is the opposite operation. Graspable math allows us to go from this line to this line just by dragging. So I'm going to take 2x and drag it over to the other side, and hopefully it'll change its operation. So if I go and just try and grab it like this, you'll see that just the 2 comes. So that's not what I want. If I try the x, that's not going to work either. So to grab both the 2 and the x, I'm going to push my shift button down and click on the 2 and the x, and you see they turn blue. I'll let go of shift, and now I can move the whole thing. And I'm going to move it just in front of the 12. And look, in one step, it's gone from here down here. And it knew to do the opposite operation because it has to do the inverse. And now I have the equation y equals negative 2x plus 12 in one step, and I can get my equation. This is the beauty of graspable math, is being able to go back and forth like this. All right, now let's go off and try it in a different example. So in this one, we want it in y equals mx plus b. In order to do that, I got to get the y by itself. So I need to move this 2x. I move by subtracting 2x from both sides. So I could do it like the top method here, where I subtract 6x, subtract 6x. But instead, I'm going to move it and see what happens. So again, I'm going to push shift and click on the 6 and the x. and drag it to the other side. And since the opposite operation to adding is subtracting, if I move it in front of the 8, it does the subtraction. Subtract 6x from this side, disappears. Subtract 6x from this side, and it's negative 6x. Now, you would look at this and say, okay, it's a y equals mx plus b form. Well, it's not, because this is a 2y, and I need the y by itself, which means I have to divide both sides by 2. So again, I'm going to click on the equal sign, and I'm going to push divide by 2. The E stands for equations. I'm going to divide both sides by 2. So we've seen this step before, and if you actually divide by 2, we end up with that, and we'll get this equation. Oh, it'll feel like we divided both sides by 2. It'll feel like the 2 came across and divided. Just like the positive when it came over here was a negative, if this is 2 times y, if I drag the 2, it would become divide. Let's check that. So I'm now going to grab the 2 and bring it across, and you see how it's changing from multiplication to division because you have to divide both sides by 2. And we end up with that same step. Now, in order to divide by 2, I would click on the divide bar, but it's not allowing me because of the order of operations. It's got this plus up here and divide, and it's all out of whack. So when you divide this side by 2, each term gets divided by 2. So this is another way that it shows this. So I'm going to grab the 2. Oh, just cancel that. I'm going to grab the 2 and go up. And you see how there's little blue lines underneath that? If I let go now, it divides both of those by 2, which is a brilliant way of demonstrating it. Now, when I click on the division bar, 6 divided by 2 is 3, 8 divided by 2 is 4, and I get this equation, y equals negative 3x plus 4. I'm actually going to backtrack all the way to here because I think you could do these steps in your head. Divide this by 2, negative 3. Divide 8 by 2 is 4. And you can see those operations happening. Now it's in y equals mx plus b. And now I can easily read that the slope is negative 3 and the y-intercept is 8. So I'll go here and click on the white dot, change this to negative 3, done, and click on the white dot and change this to 4, done. I'm going to verify that this is true. So 6x plus 2y equals 8. So I'm going to go up here and change this to 6x plus 2y equals 8. And look, there's a y-intercept of 4, and the slope is down 1, 2, 3 over 1 is 3. So negative 3 over 4. And the beauty of this is, remember, in this version, it's difficult to read the slope. I bet you some of you guessed that the slope was 6. And it's not. It's negative 3 because of the operations. And the y-intercept you might have guessed was 8. It's not. It's actually 4 because you have to divide by 2. So understanding how to rearrange these equations in y equals mx plus b form is so valuable. Let's try it 2 more times. Before I do that, I just want to show you one other little characteristic here with this x equals 5. If I write x equals 5, or if I just click once quickly on the equal sign, it switches them around. Do these mean the same thing? Of course. X equals 5 or 5 equals x means the same thing. So that's going to be valuable for what we're going to do next. All right, let's look at 2 more examples. Here, I've got negative 5x minus y plus 7. So this one's not in standard form because the first one's negative, but that's not what's important. What's important is put it in y equals mx plus b form. Now, if I wanted y equals mx plus b, if I moved all of these other things, so let's move them really quickly and see what happens. Is this y equals mx plus b? Well, no, it's a negative. So I could, in order to make this positive, I'd have to move it as well. Well, now I'm just getting further away from y equals mx plus b. So I'm going to go undo and go backwards a few steps. Let's think about this even smarter. If I need y equals mx plus b, and it's a negative y here, why don't I move the y? So I could add y to both sides, or drag it over here, and it adds y for me. And that kind of looks like y equals mx plus b, it's just the y's over here. But remember, just like I demonstrated up here, x equals 5 and 5 equals x mean the same thing. So if I just click once on the equal sign, it puts it in the form that I'm used to seeing, y equals mx plus b. And now I can quickly read that the slope is -5. So I'll go and click on the white dot, change this to -5. And the y-intercept is 7. So I click on that, change that to 7. And let's verify -5x minus y plus 7. -5x plus y equals 7. Is it plus y or minus y? Right, minus y plus 7 equals 0. There's the equation. All right, let's check. -5x minus y plus 7. I just read the wrong line. There we go. All right. Now, is this actually have a slope of -5 and a y-intercept of 7? Yep, it's going through at 7. And if I go down 5, 1, 2, 3, 4, 5, and over 1, indeed it is the slope of -5. All right, great. So one last one. This one you'll see it feels a little bit like that, where we're going to rearrange. The y is positive, so let's leave it there, and we'll move everything else over. Now I could push shift and select all of these to move them all. But if there is an operation in between, you can just grab the negative and it'll work as well. So I've changed that. It's adding 3x to both sides. And now I have to divide by 5. Now, just like I divided by 2 up here, it was really nice and easy. Sometimes when you divide, it's not going to divide nicely. So if I take this 5 and divide it by both of them, 3 divided by 5 is not a nice number. So it leaves it as the fraction 3 over 5, which is actually easier to read because that's a rise of 3 and a run of 5. But 10 divided by 5 is 2, and there is a great equation of a line. If I wanted to just go back one step like this, you can see that 3 divided by 5 is just 3 over 5, and 10 divided by 5 is 2. So the slope here is a fraction this time, 3 over 5x. Now you can have the x up there or the x beside it, it doesn't matter. So I'm going to go here and change this to 3/5. It knows to change that to a divide. And the y-intercept is 2. Again, I can verify this on Desmos. -3x plus 5y equals 10. So -3x plus 5y equals 10. Make sure I did that right. Yep. And now let's check. There's a y-intercept of 2. Good, because I had a y-intercept of 2, and the slope is 3 over 5 apparently. So if I go up 3, 1, 2, 3, and over 5, 1, 2, 3, 4, 5, I'm right back on the line. So that works out very, very nicely. Okay, so this is rearranging into y equals mx plus b in order to figure out the slope and the y-intercept. Hopefully you'll be able to manage this on your own. And so what I've now done is created a blank worksheet for you to go off and manipulate and figure out the slope and y-intercept of 4 different equations. And I've assigned this to you in Desmos. Now, if you are struggling with this graspable math and you'd rather just do this by pen and paper, then you're welcome to just write this on a pen and paper, scan it, and send it in. But if not, I really would think you would enjoy using graspable math. So in order for me to assign a page like this, it's not like Google where I can just give you the page and it makes your own copy. I have to send you a link. So here's what the assignment looks like. I've done a fake one up in a test classroom, but yours is going to look very similar. There'll be detailed instructions here. This video was going to appear right here, but here's the link to the canvas. So if you click on this link, it'll open up the canvas on your screen, and you'll have your own version. Your name eventually will be up there. Okay. Now, for starters, depending on your screen size, you might not see all the questions. So I have a pretty wide screen, and I've purposely done this. There are 4 questions for you to do. One here, and you might have to move your cursor over at the bottom here to see the other question. But there is 4. There's number 3, and move over here is number 4. Okay? If you do have a wide screen, you'll be able to see them all at once. Now what you're going to do is rearrange, just like we did, and actually go off and solve these. All right, and figure out the y-intercept. And when you're done making all your things, you need to save this. Okay? It is important that you know after you're done rearranging, you must save. If you try and share it with me right now, it will share a blank screen because you haven't saved your work. So you're first going to go off and push save. It won't allow you to overwrite my worksheet, so it's got my name on it, but you're just going to push duplicate. Now you might have to sign in, and you can sign in with your Google. Okay, so if it does say log in, you're just going to click on the login button and sign in with your Google account. But once you're logged in, you're just going to push duplicate, and it's saved. And now you see it says a copy, and when you hand it in or share it with me, it'll say your name on that. So a very important step is to save. Now you're going to copy. How are you going to do that? You're going to share it, with me by using a link. You can't assign it to Classroom because I haven't set it up that way and it doesn't work as well. You could, I don't want you to email it to me or embed it. You're just going to go to link. So here's your link. Share with others. So if you click on this, it'll highlight. You can push Control C or copy. Once you have that link, you're now going to go back to the assignment. So here's the assignment, and you're going to hand in a link. So you go add or create, and then normally you're adding or creating, giving me stuff your Google Drive. Here you're now going to give me a link. So you're going to push paste or Control V, add the link, and I will see your work right here. Okay? So, and then of course you're going to push turn in. So it's important that you remember that what I'm doing in this work is sharing you a link. You need to save your work and share a new link back with me. And that's how you'll be handing in this work. If you're really struggling with the software or with doing this and you want to do it by pen and paper, then you can do that instead. And instead of sharing me a link, you're going to share me a picture of it or a scanned version of the work. Okay? Regardless, I hope you really find this helpful. You might want to go back and have the video ready for you as you're doing the assignment just to see my steps and duplicate them. But I've tried to make the worksheet questions very similar to the ones that we just did. All right, so best of luck, and I hope you enjoy playing around with Graspable Math to solve y equals mx, or standard form and y equals mx plus b.